example, and imagine you are working for a restaurant supplier, like an imaginary company, and yeah, your job basically is you're an intermediary between producers, factories, other suppliers, and you deliver the ingredients to the restaurants every day. Of course, I mean, you're a modern company, you have software processes for this. Like all your delivery processes, they are captured in software and it works autonomously. The challenge comes whenever you get a request that is not captured by your processes. For example, you have an important customer that wants this one specific thing today, this evening. And of course, it's an important customer, you want to help, so what do? And in the old world, you start getting creative. You might calling your suppliers, do they have some extra lobsters? Or you might renegotiate orders with other customers to find these extra lobsters. And well, the good thing is, even if it's not a process today, you can do this with AI assistants. You can have an AI agent that actually takes over and dynamically, and that's the important bit, like a process that is not like written down somewhere, that this assistant kind of does this automatically. It might call the suppliers or actually, discuss the existing orders. And I'm going to show you today how you need to set up your enterprise to build such AI assistants. It's not about using them, it's really about building them. And to do so, I start with some foundational concepts of AI engineering. I'll discuss why we need a dedicated platform for it. Then we take the step back and look what a platform actually is. Then we talk about the capabilities an AI agent platform needs, first in the MVP scope, then on a few more advanced features, and we close with an outlook on the agentic enterprise. I start with the foundational concepts. I guess everybody has an understanding of what an LLM is, a large language model. I'm not explaining you like the internals. However, I want to bring us all on the same page regarding some key characteristics. And so I'm telling you the obvious thing. You ask a question, you get an answer back. And it's a probabilistic model that kind of predicts answers. And if you do it again, you might get another answer. That's actually good, because if you're not happy, you just rerun it. You redo it until you're happy. There are some advantages, but every software developer knows non-determinism is difficult to deal with. And technically, it would be possible to make LLMs deterministic, but practically, this has basically no relevance, because we are losing this advantage of retrying and losing creativity. But also, if we only would change the input slightly, we still have the effect that we get something else. So I think it's safe to assume LLMs are non-deterministic. The next concepts that I want to introduce are agents. Agents are now software systems that act on behalf of the user and can autonomously execute tasks. And to do so, an important concept, these agents make use of so-called tools. Tools can be functions or resources that the agent calls or accesses. On the right side, we have here an example of that. The most important bit is the agent application on the top left, and that is kind of code that interacts and basically translates the LLM outputs to tool calls, calls these functions, and gives the answers back to the LLM, which is then generating the final answer. Like this is just an exemplary thing. If we follow this example that we want to have maybe an assistant that helps planning meals, then you would maybe provide this agent tools to search recipes, check the fridge content, and then finally create a shopping list. So why do we need an AI agent platform? On one hand, you can say AI agents are not that different to microservices. Agents have very small code. I would even argue that most agents are much, much smaller than microservices. So they can be easily containerized. Ideally, they are implemented stateless. And also on high level, they provide an API and they consume other APIs. Basically a microservices. Of course, there are a few aspects that are a bit different to the typical microservice. And first of the things is they are difficult to test. You remember the non-determinism. They have a high latency. Everybody who has worked with LLMs knows we talk here about multiple seconds, if not even minutes. That's very different to what we are used from classical software and maybe database accesses. And the other problem we have is, as this agent is deciding autonomously on what tool it calls, also from the outside, it's very difficult to understand what's going on. And for us, it's difficult to explain it. But I think we should build up on the similarities we have. And from my point of view, it does not make sense to build something completely from scratch. Instead, we should leverage platform capabilities that we already have. So having this microservice platform where you can run the agent, but there are also similarities with data and ML platforms. Just as you think about having a data pipeline that kind of builds the baseline for an agent. So these are a lot of things we already have in place, and we just need to bundle them together and provide it as a dedicated platform. The other specific challenge with this AI is scaling. Everybody who has implemented a small AI application or agent probably knows that you need a few lines of code and you have very impressive results. I don't know, 20 lines of code and like your manager is flashed. The challenge is everything that comes after that. Making sure it's not only working once, it's working the majority of time. Making sure it's secure. Does it actually solve a real business problem? Is it cost efficient? Also a topic like if you have like a prototype, you just use the most expensive LLM. But if you want to roll it out to thousands of users, it's a different challenge. Yeah, and lastly, of course, operating it. And that is an aspect I think a platform should support the AI engineers with. Yeah, talking about the AI engineers, what are actually the users of our platform? We have this idealized AI engineer, but actually it's a very new discipline. So it's very unlikely that in your enterprise you have a lot of people with exactly the skill set you need for building AI applications. Instead, you have a lot of different roles that are your potential users. For example, you have microservice developers that maybe on top of their APIs directly want to implement an agent that allows interacting with their domain. You may have data engineers that use or that provide agents to explore their data products, or data engineers that of course also support in providing data for your AI applications. Lastly, data scientists, they on one hand can also use agents to create, for example, reporting, but of course they are also like the experts if you really want to get and squeeze out the last bit of it. Of course, that is not like looking at these different personas. That is not new to AI, but I think we have it emphasized here that we will have a lot of different users with very different level of expertise. And if we think about what this platform needs, these are just a few examples. We soon learn that we actually need to provide these capabilities in different like degrees of complexity. And if we now look into our personas from earlier and like represented by the typical T-shape, we might have the software engineers that are very experienced with like DevOps practices that are more or less applicable also to agent development, but they have probably gaps on the more data and AI side. This is where the other personas fit in. The data scientists that are maybe the expert if we are really talking about fine-tuning models, and data engineers that can help and set up data access. And What does this mean for designing our platform? We often see that people focus on the average user. And we think that's actually not a good idea in this context because the users are too diverse. And we believe a much better approach coming from product thinking is the idea of designing for the extremes. So really focus on the beginners, the ones that do not know a lot of AI engineering yet, and also on the experts that maybe have this very specific needs. And if you make both of them happy, I think your average user also will be happy on the long run. The last challenge that I want to cover with AI is it's currently obviously a hype. People are putting AI on everything. And I think to a certain degree that it's important because it's a new fascinating technology and we have to learn what is possible and figure out. But again, from an enterprise view, we have to look behind this hype. So really need to understand if AI solves the real business value. And also, there are techniques in place to do this. And the one thing that we are recommending is rapid prototyping. Quickly build an agent. And I mentioned this initial wow factor that it never has been easier to build an application. That's something to leverage here. Quickly build the agent and make sure you can roll it out to your first pilot users so that you really get real world feedback if it solves a problem. Again, I mean, these are just all like input. So what are the challenges we want to solve with our platform? And these are aspects in which we need to support the AI engineers. Yeah, I've mentioned the word platform already a few times. So let's quickly look what a platform actually is, because I think a platform is a term used a lot and everybody has a bit of a different idea. Yeah, I brought this quote from Evan Butcher. Digital platform is a foundation of self-service APIs, tools, services, knowledge, and support, which are arranged as a compelling internal product. Autonomous delivery teams can make use of the platform to deliver product features at a higher pace with reduced coordination. Okay, let's look into this and understand it. The first thing I want to emphasize is why do we have a platform? This is the last bit. It's about making teams faster by taking cognitive load away from them and bringing this into the platform. And the other thing is what a platform is. That is purposely very blurry here. And it's basically everything that can help teams. So it says knowledge and support. So in the easiest case, a platform is just documentation that helps teams to navigate and work faster. Yeah, after having here a definition, I want to also give like a bit of a metaphorical definition. And you might have seen it by now. The theme of my talk is everything food related. That's why I have here taken concepts. This one is from the French cuisine. And what they do there, or like a concept, what they have there is that before they actually cook the meal, they prepare all the ingredients and set everything up nice in the kitchen. So when they do the actual cooking, they just have to grab the stuff and can move fast. And that is the first thing that your platform needs to fulfill. And that is especially important for the expert users, that they have everything in place and just pick the things and can then cook their AI applications with whatever ingredients they need. On the other end of the spectrum, looking now more at our like beginner users, we have another concept from restaurants. Now it's from Japan, omakase. And the idea behind this is, and I think a lot of us will feel like this, if we go to Japan, we don't really know what we like, what we don't like. And instead of randomly picking something from the menu, we can leave the choice to the chef. And that's the same with AI engineering. A lot of teams are new to this domain. They don't know yet what they need. And so they need a recommendation basically from the platform. Yeah, we have talked now why we need a platform, what a platform is. Let's look now into the capabilities of such a platform. And I'm starting with really the most foundational and basic capabilities such a platform need. And yeah, this is driven again by the rapid prototyping. So what do you need to make this possible? And I'm starting with the most obvious one. Of course, you need access to LLMs. Without LLMs, you cannot build AI applications. And technically speaking, that is very easy. All the model providers, they have APIs. You get an API key. You can call the API. Simple. Even most cloud providers have allow access to LLMs. I'm not telling you anything new here. But from an enterprise view, the challenging parts are more about organizational and like compliance things. This is what makes that what potentially slows down the teams. So make sure that there are processes in place, that they get access to these APIs, and that using those LLMs is compliant and yeah, follows your organizational principles. The next aspect is, if you have this prototype ready, how do you get it to your user? So you need some kind of runtime. And our recommendation clearly is here to leverage what you have already in place. So make sure that agents can be deployed in a simple way on your existing microservice platform. Why should you not start something new? It's all the things that you add on top. The more you progress, of course, you need security, observability, and all those things. And if you would have a completely parallel infrastructure, you would need to set up all these things in parallel. And if you make different technology choices, you are increasing the cognitive load for your teams, because then suddenly they have to deal with different solutions. And therefore, our recommendation really is to leverage capabilities that are there. The third aspect are vector stores. Why are vector stores important? We still see that this is the most basic AI application pattern that most teams, when they start building AI applications, this is where they start with. And that is the RAG, the retrieving augmentation generation pattern. In a way, it's pretty simple. So you have a database, and depending on the user prompt, you query this database, and the responses from the database are fed into the LLM that generates the final output. And the nice thing about vector stores is that they allow for a similarity search. So you do not have to search for keywords. Instead, you can find similar results, and therefore they make the search is so easy possible. What does this mean for a platform? Start simple. There are in-memory vector stores. Recommend this to the users to really get started. Next, leverage capabilities of existing databases. I don't know, for example, Postgres, there's pgvector extension. MongoDB has vector search capabilities in it. Probably many other databases have these capabilities today too. And only really look into specialized vector stores if there's a real need for that. Again, avoiding complexity where not needed. The fourth point is having UIs. Because if you want to test and validate the business value, you need to share with the users, or like your teams need to share with the user. And this, of course, does not really work with only a REST API. We made very good experiences with like Python-based front-end tools, Streamlit and Gradio. So you can build with a few lines of code like visual, appealing UIs. Of course, there are limits, but this is really the thing to move fast and implement front ends quickly. If you have a lot of front-end developers, I would also recommend looking into the HGUI protocol and the JavaScript implementation of it, the Copilot kit. It's now supported by different agent frameworks, and it's basically a protocol for the interactions between front-end and back-end, so that you can focus on the visualization and don't get slowed down by these technicalities especially in this rapid prototyping phase. I mean, the more you progress, the more specific your things get. Probably makes sense to think about this, but especially in this rapid prototyping phase. use things that are out there already. Yeah, and now coming back to this idea of omakase, like you've seen, the really the foundational concept is not that much that you need to get started. So the next thing is how to tell your users about it. And the easiest way is really having reference implementations, blueprint projects, where you bundle those decisions that we just discussed, that you bundle this together, and that you have this paved road to production that your users can follow. This might include a default agent framework, the vector store database setup, the prototyping tool, and of course, deployment pipelines, CI/CD integration, and so on, that the agent at the end really runs in an environment it can be accessed by users. I think it's important for every platform, but it's especially important for the AI platforms that you should encourage your users for alternative ideas, for deviating from the solution that you've seen. We all know the AI space is super fast-paced. So a technology choice you might make today maybe doesn't make sense in 6 months from now. And therefore, be open for this change and also use this as a feedback channel when users use different technologies. Maybe that's something worth integrating into the platform. So after we have talked really about the foundational capabilities, I want to give a glimpse on a more advanced setups and more advanced capabilities. Unfortunately, the time is limited today, so I won't be able to talk about everything, but I picked out two, evaluation and distributed tracing. Let's start with tracing. We basically get back to the example from the start. We have this agent that can autonomously call these tools. And this autonomously is what makes it exciting, but which also makes it very hard to predict what's going on. So in a way, this agent is a black box. We don't know what's going on. And luckily, there are solutions that already exist and turned out to be helpful. And this is basically, microservice developers know it from distributed tracing. This also works like if you only look into one agent, like the same idea. You implement a tracing library in this agent, and then this agent kind of sends out what it does. And if you have an open telemetry backend, you might see like a call hierarchy shown similar to this one shown here. You really see the steps. And on top of that, you can attach a bunch of metadata there. So if it's an LLM call, you can actually attach the prompt that goes to the LLM. If you have a search, you might attach like the query that goes to the search or the search results. And so the tracing are your eyes into the agent and help you understand what's going on. Yeah, I said technologies that are out there already, we are just reusing them. There are a few key differences that I want to highlight. The first one that I mentioned already is like this attaching of additional metadata. Like in a microservice world, typically you do not attach too much metadata. I don't know, maybe a few call parameters, correlation ideas, timestamps, stuff like this. Now, when we talk about attaching prompts, maybe search responses, like this blows up. So the size of the metadata is much bigger than it was previously. The next challenge we have is PII data. Again, in a microservice world, you kind of control what you attach to it. But if you forward user input to the tracing system, it's a bit out of your control. Of course, you can apply certain cleaning techniques, but like this will never work 100% because we are in a kind of uncontrolled environment. And so it's important to make sure like that the data storage of this tracing data is compliant and can deal with PII data. And lastly, what also makes sense, that is like maybe a different way to think about tracing, that it also gives you, that it can be used for business insights. For example, you can directly attach user feedback. Were they happy with the LLM response or not? And of course, a big topic in AI application development are costs. So directly attach the cost to it. And if you then have like this call hierarchy, you can see what consumes the most costs, what can be optimized. So it's really the most important way for introducing observability on AI applications. The second thing I want to talk about is evaluation. Yeah, everybody is aware of testing in software. I don't want to say it's easy, but like at least this example is easy. I think it's obvious. And the good thing is here we have a clear answer. If we talk about a generated response, we don't have this clear, correct answer. Just as an example, if you look at this, I hope we can all agree that the third option is a no-go. But of course, which of the first two is better? It's not that easy to say. And if you go further, the LLM might output other things. So while we said the cat is maybe not correct, the other thing is maybe not relevant, or the agent might not polite. So there are different dimensions in which you can decide if an AI application performs well or not. And looking at the last question, what are your dietary preferences? That actually might be a good answer. It really depends on your business context. To decide. And yeah, it's not easy. The good news is, as a platform, that's not our challenge. That's the challenge of the AI engineers. However, of course, we need to support them with providing them the necessary infrastructure. And that is shown here. What do we have here? So first of all, we need basically track all these evaluations, because that is the key for reproducibility, that you know what you're evaluating. First of all, we need to track and manage like the evaluation dataset, the questionnaire basically. Then the prompts and parameters used in the AI application to see what changing a prompt, does it have an impact and so on. So that at the end, we can have like a clear lineage between all these things, bringing them together. On top of that, of course, we need an environment where these evaluations get executed at the start. Probably it works on the dev machines, but the more complex it becomes, if you want to run parameter variations, like you want to scale, you want to run different pipelines. Again, I don't think it's a capability that needs to be implemented from scratch. We have CI/CD systems, or like thinking about data platforms, there often are also capabilities to run data pipelines that can be reused here again. And lastly, important thing also is how much automation we do on this evaluation. There will always be the one bit that the human needs to decide at the end. And so it might make sense to directly think about integrating this human feedback in your setup, so that they can annotate and maybe add notes to executed evaluations. Okay, now we are heading a bit to the outlook, the agentic enterprise. And I want to go back to this example at the start. What we had there, now a bit more abstract, is that we have here one workstream agent that does a specific task, and it autonomously discovers and calls other agents inside the enterprise. For example, agents that allow interactions with microservices, or agents that allow interactions with data products. This is where we want to get to, and what do we need for this? First of all, the protocols. And I think MCP is not new anymore. It's widely adopted, especially in this coding assistance. Everybody who uses Cursor, GitHub Copilot knows this. That is the common way of giving those tools more capabilities. This, of course, also works if you implement your own AI agent. If you don't rely on this coding assistance, but implement an agent, an AI application, it's kind of the same mechanism. It's a protocol to provide additional tools. And yeah, And I would say it's very widely adopted, as much as you can say, in this fast-paced AI environment. Not that much adopted, but a still very interesting candidate to look into is the agent-to-agent protocol, initially introduced by Google. This is a protocol for more complex agent interactions. So if you want to pass state, handover between agents, that's the thing to look into. But I think at the start you get quite far with MCP. Yeah, I quickly want to also mention the topic of security. This was an example in May, and I think it's a very classic one, privilege escalation. An AI assistant used an MCP server, and this MCP server had more privileges. Classic problem of privilege escalation. Yeah, looking on all this high level. So we have this challenge that we have multiple agents interacting with each other. We have to make sure like the security is passed between them correctly. So I'm asking this provocative question. Haven't we seen this before? I don't know, 10 years ago, this was the slide in every microservice talk, the architecture of Netflix. While still deterministic, we already had the problem that humans could not understand the actual interactions anymore just because it was too much. And I would say we are here again in a very similar situation. And even if it feels like AI is reinventing everything, I think we should not forget that we have tools in place on this, and that is also my answer to this. So what solves agent discovery? In the microservice world, we have a service registry, authorization. Important is a clean and global implemented OAuth and access token system. Of course, this does not prevent all security threats, but it's like the most fundamental thing to do. And lastly, monitoring the interactions. We talked about this earlier in the aspect of only one agent. Of course, this also works in a distributed agent setup using tracing, getting insights here. Yeah, and that brings me to the end of my talk. I just want to summarize it and highlight the things. I think there's really a need for a certain degree of AI agent platforms because we have a few dedicated challenges. Not everything is just all things done new, but there are certain challenges that need to be addressed. Having a dedicated platform does not mean we have to reinvent the wheel and start with everything from scratch. Instead, we believe it's much more beneficial to leverage existing capabilities and platforms that you already have. And lastly, to really help your teams to move fast, provide them recommendations and a paved way to productions so that they can experiment and try out these new technologies quickly. Yeah, that brings me at the end, and I couldn't resist to start with a little bit of promotion. I'm working with a colleague who is not here today on a book where we go much deeper in the few things I could share. Please follow us on LinkedIn or follow the link. And there's more to come. All the things that I just scratched that I'll be able to share a bit more. Yeah, and that's done it from my side. I'm happy for questions.
Yeah, question.